Hi everyone, thanks for watching my YouTube contents. I'm Sang Kim. In the previous video, I showed you how to estimate parameters for Weibull Survival Analysis with covariates in Excel and R. In this video, I would like to show you how to get standard errors of Weibull Survival Analysis with covariates in Excel, which is same as R output. Right, so let me quickly show you how to estimate coefficients based on this log likelihood function. So x variable is actually log of every time, right? Then let's set initial value for b0, b1, b2. So b0, again, I normally use average of log of every time, okay, around 6.39. So let's say 6. And then b1, 0 as an initial value, and b2 also 0 as an initial value, and sigma 0.1, because sigma cannot be 0, right? Then z variable can be calculated by log of every time minus b0 minus b1 coefficients times rx minus b2 times age and over sigma. Right. Then log likelihood can be calculated by if FUStat equals 1, then we can use this gray part. So z minus exponential of z and minus log of sigma. If not, we can use negative exponential of z value. All right. Then sum of log likelihoods. So we want to maximize this sum of log likelihood while changing these coefficients. So click data and go to server. Okay, and set objective from sum of log likelihood. We want to maximize it by changing variable cells. This one. And uncheck this box and click solve. Okay, again, as I mentioned in the previous video, we need to click more until it doesn't change anymore. Okay, and click again. Okay, it doesn't change anymore. Right, so this coefficient is almost same as our output. Again, the small difference comes from different algorithm. Log scale is log of sigma. Right, this is how we can estimate coefficients by using Excel, right? So let me show you how to get these standard errors and z and p-value in Excel. So there's one reference book I have used for this book. There is a matrix information matrix formula to calculate standard error, right? But actually there is 1 over sigma hat squared. So we need to be careful when we use this one, when you calculate matrix computation, right? So let's copy z value. And again, as you can see, V matrix consists of diagonal of e to the power of zi. So exponential z. Then we need to make a V matrix by using exponential of z. So if equals this one, then let's get exponential z value, fixed column. If not, let's give a value as 0, and Control C and Control V, right? So I use conditional format to highlight diagonal elements, this one, and let's give a name in Excel. Let's say as a V. And then also let's give a name for X matrix. So I added one more column here to make it design matrix. So let's give a name as X. And for column Z, let's give a name as Z. Alright. Then let's get information matrix by using this formula. The first part is X prime times V hat times X. So emerge transpose of X comma V, and again emerge comma X and over sigma squared, this one, so sigma squared, and press Ctrl Shift Enter. Right, and this one X prime times V hat times Z hat. So emerge transpose of X comma V, emerge comma Z, and divide by actually sigma, not sigma squared, this one, and then press Ctrl Shift Enter. Okay, and this value is same as this one, and just transpose values. The last part, this one, M is actually sum of events, and we don't need to you don't need to multiply by 1 over sigma squared. This is one thing we need to be careful. Anyway, let's get emerge transpose Z comma V, and again emerge comma Z, okay, and plus sum of events, and press Ctrl Shift Enter. Right. Then we need to calculate inverse of information matrix and inverse of information matrix. Press Ctrl Shift Enter. Okay. And the diagonal elements is actually a standard error for each coefficient. So standard error for B0 can be calculated by square roots of first element and square root of second diagonal elements, and for V2 square root of third element and square root of first elements. Okay, then Z value can be calculated by coefficients divided by standard error. And again, this one, we need to, in R, actually use log scale. So let's change it, log scale of standard error. Okay, so this is same as R output. And p-value can be calculated by two-sided test. So 2 times 1 over normal distribution of value, comma mean as 0 and standard deviation as 1. And then true cumulative specify cumulative distribution. Okay, and let's use absolute value of Z. then Control C and Control V. Okay. Okay, as you can see, this is same as our output, right? The small difference actually comes from small different coefficient values. Again, this is because of different optimization algorithm, I think. But as you can see, we were able to get p-value. Then again, under 5% significance level, we can say that V2 and sigma is significant, right? So the main purpose of this video is to calculate standard error by using information matrix. This information matrix is come from actually second derivative form of log likelihood. I hope it was useful to understand how to calculate standard error by using information matrix. Please click like and subscribe if it was useful for you. Thank you.